Hi, in this lesson we will be talking about how to rationalize the denominator. Given an expression with a radical in the denominator, I will be able to rationalize it into simplest form. What does it mean to rationalize the denominator? Let's say we have something like this. 3 over the square root of 5. Notice how we have a square root in the denominator. Although this is a correct answer, usually we don't like writing it like this. We want to get rid of the square root in the denominator. So what can we do? This process is called rationalizing the denominator. First, I'll go over the mathematical steps of rationalizing the denominator, and then I'll go through a little shortcut. So I have 3 over square root of 5. That's the same thing as 3 over the square root of 5 times the square root of 5 over the square root of 5. And this is because the square root of 5 over the square root of 5, or radical 5 over radical 5, equals 1. So we're just multiplying by 1. Nothing really changes. We're just trying to write this in a different format. So I'm going to multiply both the numerator and denominator by the square root of 5. So now I'm going to have 3 times the square root of 5 over the square root of 5 times 5. And I can further simplify this. Numerator just stays the same. The bottom, 5 times 5 is 25, so I have the square root of 25. Notice that 25 is a perfect square, so I end with 3 square root of 5 over 5. So this is equal to 3 over the square root of 5, which is what we started with, but we wrote it differently and we rationalized the denominator. Notice how now in the denominator we don't have that square root. So this is the mathematical way of rationalizing the denominator, but let's go over a shortcut. So we have 3 over the square root of 5, and what you can do is have a 3 in the numerator, and also in the numerator bring that radical up here. So you write the radical with the numerator, and the denominator you just write the radicand down. So you just write whatever's inside that square root. So this is the little shortcut of rationalizing the denominator, and feel free to use this shortcut once you feel comfortable on how to use it. Alright, so let's take a look at some examples. We have our first example here. Express 6 over the square root of 7 in simplest form. So I have a square root in the denominator, so I need to rationalize this denominator. So for this example, I have 6 over the square root of 7, or radical 7, whichever way you want to call it. And I want to get rid of this square root in the denominator. So what I'm going to do, I'm going to multiply both the numerator and the denominator by the square root of 7. So square root of 7 over the square root of 7. The numerator, the top part, is just 6 times the square root of 7. And then the bottom, The square root of 7 times the square root of 7 is just 7. So this is the simplest form. We have 6 times the square root of 7 over 7. And notice how if you were to use the shortcut, I kind of added color. This is how you would use the shortcut, is where the radical 7 would come up to the numerator, and on the bottom, the denominator, we just have the radicand 7. Here's our second example. We're going to express 5 over the square root of 10 in simplest form. So again, we're going to be rationalizing the denominator. So for this problem, I have 5 over the square root of 10. And if you feel comfortable, go ahead and just use the shortcut. But I'm going to walk through it for this example, where you multiply both the numerator and denominator by the square root of 10. So multiplying the square root of 10 over the square root of 10. And I get 5 times the square root of 10 over 10. But notice I can reduce this a little bit by dividing both the numerator and denominator by 5. 10 divided by 5 is 2. So this reduces to the square root of 10 over 2. So make sure even after you put the radicand to the top and everything, you simplify, because sometimes you'll have to reduce the fraction. So make sure you're simplifying all the way. For our third example, let's rationalize the denominator for 2 over the square root of 2. So we have 2 over the square root of 2, or radical 2, whichever way you prefer. And to rationalize that denominator, we're going to multiply both the numerator and denominator by the square root of 2. This will equal 2 times the square root of 2 over 2. And I can reduce this by removing that 2, and I'm left with the square root of 2. So in this case, we reduced all the way to the square root of 2. Again, the 2 over radicand 2 and this radicand 2 that we ended up with, these are the same answers, just written differently. Here is our fourth example. Express 2 over the square root of 12 in simplest form. So I have 2 over the square root of 12, and to rationalize the denominator, again, we're going to multiply both the numerator and denominator by the square root of 12. So that's this step right here. And so I have 2 times the square root of 12 over 12. But notice here, the square root of 12, we can simplify this. So let's rewrite this a little bit. I'm going to factor 12 out. So instead of 12, think back to the lesson right before this. Instead of 12, I'm going to rewrite this as 4 times 3. So I have 2 times the square root of 4 times 3, still over 12. I'm going to break this apart. I have 2 times the square root of 4 times the square root of 3 over 12. And right here I have the square root of 4. which I can simplify to 2. So let's further simplify this. I have 2 times the square root of 3 all over 12. 2 times 2 is 4. So I have 4 times the square root of 3 over 12. And I can further reduce this by dividing both the numerator and denominator by 4. And I've simplified this to the square root of 3 over 3. I know there were a lot of steps in this problem, so please let me know if you have any questions on how I went from one step to the next. Let's look at one last example together. For example 5, we're going to express 5 over the square root of 20 in simplest form by rationalizing the denominator. So I have 5 over the square root of 20, and this time I'm going to use the shortcut. So I have 5 times the square root of 20 over the radicand, which is just 20. But I'm not done yet because the square root of 20 can be further simplified. So I'm going to rewrite it as 5 times the square root of 4 times 5, still over 20. And let's split up this radical part. 5 times the square root of 4 times the square root of 5 over 20. And the square root of 4 is equal to 2. So I have 5 times 2 times the square root of 5 over 20, and 5 times 2 equals 10. So this further simplifies to 10 times the square root of 5 over 20. Let's reduce this by dividing both the numerator and denominator by 10. And I have my final answer, which is the square root of 5 over 2. I was able to rationalize the denominator and then simplify. So to rationalize the denominator means to make sure there are no radicals in the denominator. And feel free to use the shortcut when you're working on practice problems. Great job, and please remember to submit your notes on Canvas.